Today we're going to talk about radicals, how to add and subtract radicals, multiply and divide radicals, simplify radicals, and how to check your work once you're done. First, let's talk about the parts of a radical. This number here is called the index of the radical. For our purposes in geometry, this number will always be a 2. However, you should know that this number could also be a 3 or a 4 or some other number because you may run into that later on. The number here that goes under the radical sign is called the radicand. And that's going to be important because we're going to need to identify that and be able to compare radicands in different numbers. The radicand is the number we will deal with the most in geometry. So to start, let's look at adding and subtracting radicals. These are two examples of radicals that we cannot add or subtract. The reason we can't add or subtract these is because their radicands are not the same. So, for instance, I can't do square root of 3 plus square root of 6 because the radicals here are not the same. Again, I can't do square root of 3 minus square root of 5 because the radicals here are not the same. So let's take a look at some that we can do, and let's talk about how that works. For instance, I can do the square root of 3 plus the square root of 3 because notice here our radicands are the same. When I add these, I'm going to have 2 of the same thing. And this is very similar to adding together 2 x's, right? So when you learned in algebra to add x plus x, you have 2 x's. Same rules apply here. If I do square root of 3 plus square root of 3, I'm adding the number that's in front, and that number is an understood 1. Just like the number in front of the 2 x's down here is an understood 1. So when I add those together, I get 2 square root of 3. Okay, so this is my answer for square root of 3 plus square root of 3 is going to be 2 square root of 3. Now, let's try an example with subtracting. For example, I could do 6 square root of 5 minus 2 square root of 5. Again, I'm interested in subtracting these numbers that are on the outside, and I can only subtract them if the numbers inside the radical, the radicand, are the same in both problems. So both of these are a square root of 5, so I'm good there. So I can subtract my numbers on the outside. So again, just like with x's, I'm subtracting these. So if you're looking for a comparison, this would be equivalent to 6x minus 2x, right? And 6x minus 2x, I subtract the 6 and the 2, and I get 4x. Very similarly, I subtract the 6 and the 2 in the radical, and I get 4 square root of 5. This is my answer for 6 square root of 5 minus 2 square root of 5. This process works the same way whether you're adding or subtracting, so you can do that with both. So let's move on to multiplying. For multiplying, we do not have to have the same number underneath the radical. We don't have to have the same radicand. They can have different numbers. So notice here I have a square root of 3 times a square root of 6, and I can do that because I am multiplying. When I'm multiplying, I take care of all the numbers on the outside of the radical first, and I can combine numbers on the outside together, and then I can combine numbers on the inside together. So again, this has an understood 1 in front of each of these. So 1 times 1 is 1, so I still have just a 1. And then I can multiply my numbers on the inside together. So square root of 3 times square root of 6 is square root of 18. So 1 square root of 18 and square root of 18 are the same thing. Okay. Could try that again with the square root of 2 times the square root of 8. Again, these have an understood 1 in front of them, and so I multiply the ones together and I get 1. Square root of 2 times square root of 8 gives me square root of 16. And so this is the same as just the square root of 16. Now we're going to talk in a moment, both of these final answers can be reduced farther. Okay? And so it's always going to be important to check and see if you can simplify your work. Our first one, the square root of 18, we're actually going to have to go through the simplification steps, so we'll come back to that one in a moment. The square root of 16, however, is a perfect square. So some of you may already... What is a perfect square? The square root of 16, however, is a perfect square, and some of you may know that one, and it is 4, because 4 times 4 is 16. Okay? Again, we'll come back to the square root of 18 and how to simplify that in a moment. So let's look at dividing. For dividing, we're going to have two numbers, one on top of the other, like a fraction. And we first want to go ahead and practice writing this under one radical sign. So I have 8 divided by 2 under one big square root. So these two statements are equivalent. And a lot of times this will help us simplify what we're looking at. So for instance, 8 divided by 2 I know how to do. That is 4. And so I end up with the square root of 4. This is a perfect square. And so my final answer here is 2. If you have something where it is not a perfect square, for instance, if you were trying to do the square root of 9 divided by, let me write that again. For instance, if you were trying to do the square root of 9 divided by the square root of 27, you have to, again, write those both underneath the same radical sign. And then we can simplify that. And in this case, that's not going to be a perfect square. We're going to end up with another fraction, which is 1/3, right? So from here, we could also break this back down into its component parts, square root of 1 and square root of 3. And from here, we have a bit of a problem. And so you can't have a radical in the denominator. So it is an issue here that we have this square root of 1 over the square root of 3. It's fine to have the square root of 1 in the numerator, but you can't have the square root of 3 in the denominator. So our next step is always going to be to multiply by whatever that radical in the denominator is over itself. So you have to multiply it by the number in the denominator over itself. In this case, that's square root of 3 over square root of 3. In reality, that means we're multiplying times 1, but because math is magic, you are going to find that this will actually solve our radical in the denominator problem. So we're going to go ahead and multiply that. So the square root of 1 times the square root of 3, we multiply those radicands and we get square root of 3. And the denominators we multiply, that's square root of 3 times square root of 3. So 3 times 3 is 9, so we have the square root of 9. And if you do this correctly, every time this denominator is going to end up being a perfect square. If you didn't do it correctly, you will not have a perfect square in the denominator, and you will know you need to go back and try again. Okay? And so the square root of 9 divided by the square root of 27 is equal to the square root of 3 over 3. And this is our final answer. Okay? And again, in a minute, we'll talk about some ways that you can double check your work and make sure you didn't make any mistakes, because I realize that there are a lot of steps here. So first, let's talk a little bit about simplifying. When you're simplifying, you want to make a factor tree first. And we're going to simplify a perfect square first so you can see how that works. And I think it makes the rest of this process seem a little bit easier. So I make a factor tree, and I can divide 2 into 4, and I get 2. So the two factors for 4 are 2 and 2. When I have a pair that's at the bottom of their factor trees, like I do here, I can pull one of those numbers out. So I have 2 2s, so I am going to pull 1 2 onto the outside of my radical. Okay, so I can take one of these and put it on the outside here. Okay, I don't have anything else left over, so I actually get to get rid of my radical in this problem because this one is a perfect square. So my final answer for the square root of 4 is just 2. All right? Now, let's take a look at something a little bit more complicated. Earlier today, we found the square root of 18 as one of our answers. And for my class, you would have to simplify that. So we want to be sure you know how. So we would make our nice little factor tree. And if there's more than one way to factor your numbers, that's fine. You can use any of them. I am going to factor this into 2 and 9. Okay. And then I would factor any of these numbers that can be factored again. So 2, I can't factor any farther. It would just go to 2 and 1. But 9, I can factor into 3 and 3. And so I want to go ahead and do that. Now, I'm interested in my pairs, right? That's the first thing I want to identify. So I have a pair of 3s at the bottom of the factor tree. So I can pull one of those out, and it goes here on the outside. Remember, for every pair, I pull one of those numbers out. I also have this poor, lonely little 2 over here that still is on the inside. And I always tell you to put that into a box because if you notice, our radical sign looks a bit like a box. And that will help you remember that whatever's in the box has to go back inside the radical. Okay, so our 2 has to go back inside the radical here because it was left over. It didn't have a pair, so it doesn't get to come outside. Okay, so you'll notice the square root of 18 is equal to 3 square root of 2. Keep in mind, if you had chosen different numbers for your factor tree, you would get the same thing. So I'm going to show you that really quickly. Just a moment to clean this up. So if, for instance, instead of choosing 2 and 9, you had gone with 6 and 3. Okay, so that's still a valid factor tree for 18. I would break down my 6 into 2 and 3. And you're going to notice I still have a pair of 3s at the bottom of the factor tree. So these 3s can still be a pair because they are at the bottom of the factor tree. I still have a 2 left over by itself. So I can still pull out a 3. It goes on the outside here. And I still have a 2 that has to stay on the inside of the radical because it doesn't have a pair. Okay. So now let's talk for a moment about how to check your work here. So we came up with 18, or the square root of 18, and 3 square root of 2, and we found that those are the same thing. So I want to check my work. So if I type in the square root of 18 into my calculator, I get 4.243. If I want to check and see, did I do my work correctly? Is 3 square root of 2 the same thing? I would type in 3 square root of 2 into my calculator. And if I get the same decimal, which I do, then I know that I did all of my work correctly. So even if you can't use your calculator to simplify your radical, you can use it to check your work at the end so that you'll always know that you did those steps correctly. Good luck and have a wonderful day.